Hello there, my name is Charles Sugasfan Msipo. Welcome to another presentation of an example of checking whether the function is analytic and then later determining the derivative of the given function. Our exercise here is as follows. Given the function f of z is equal to e to the power 2z plus 3z plus 1, determine if the function is regular, and if it is, find f prime of z. So remember that regular is equivalent to analytic. Now let's present our solution here as follows. Now remember, our initial step here will be to recall the Cauchy-Riemann equations, which say that delta u, delta x is equal to delta v, delta y, and delta u, delta y is equal to minus delta v, delta x. And then, as noted, this is a Cauchy-Riemann equations. They must be satisfied if the function is regular or say analytic. Now, our next step will be to take this function and write in terms of u and v, which are functions of x and y. In other words, we need to express fz as f of x, y, which equals to u xy plus the imaginary unit times v of xy. So then we need to grab our function there and recall that z is equals to x plus the imaginary unit times y. So plugging in z in this expression, we should get something like e 2x plus imaginary unit times y plus 3 times x plus I y all squared plus 1. Now we need to simplify this and now separate the imaginary, have the real part and the imaginary part on its own. And at this stage, we need also to remember this identity, which says e to the power I theta, where theta is an angle in radians. This is equal to cos theta plus I sine theta. We are going to use this when we apply the rules of exponents here and have e to the power 2I theta. So simplifying here, we have e to the power 2x multiplied by e to the power I 2y. Here we're applying the rules of exponents, same base, and then that is the product. Plus, we've already seen this. This will be 3 brackets x squared minus y squared plus 2x y times the imaginary unit close plus 1. Now simplifying this, we get e to the power 2x brackets cosine 2y plus I sine 2y, call here applying that identity, plus 3x squared minus y squared plus I 6 multiplying this 3 by 2 xy plus 1. At this point now, we can now isolate our v and u. Now taking the real part, now is talking about the terms without I. We are having here, note that here e to the power 2x is a common factor for these two terms. Then collecting the ones that I to be e to the power 2x cos 2y plus this term here that I, which is x squared 3 times x squared minus y squared plus this 1. Then plus the imaginary unit times e to the power 2x multiplying sine e to the power 2x sine 2y plus 6xy, and then so at this stage now we have our u here and our v there. So let's write here, say this is our u of xy, and this in brackets is our v of xy. Now we can now write this specifically and say u of xy is equals to e 2x cosine 2y plus 3 x squared minus y squared, and of v xy equals to e 2x sine 2y plus 6xy. Now from here we can now proceed and do our checking of Cauchy-Riemann equations. Then differentiating partially delta u, delta x. This is a constant and that is a constant, so differentiating here would get the derivative of exponential function, which is the exponential function itself multiplied by its derivative, which is 2. So 2e to the power 2x multiplied by the constant cos 2y, plus coming here differentiating this function. This is a constant with 0, then differentiating x squared, it will be 2 times 3, which would give us 6x. I hope you note that we're using power rule there. The next is delta u, delta y. Differentiating in this case here, this is a constant which you can consider as an amplitude of cosine, and then differentiating cosine multiplied by the derivative argument will give us 2, then cosine is minus sine, then we get minus 2 e to the power 2x sine 2y, and differentiating this side, this will be constant to be returned to 0, then this one will give us minus 2y multiplied by 3, which is going to give us minus 6y. And coming to v, delta v, delta x will give us again the same derivative of we had there, which is going to be 2e 2x sine 2y plus 6y, and delta v, delta y. Now we have that this is a constant. We're differentiating to y, then derivative of sine is cos, derivative argument is 2, then we're going to have 2e 2x cosine 2y plus, with respect to y here, we're going to have 6x. Now our task is to compare the derivatives. So we write down here delta u, delta x is equals to e 2x cosine 2y plus 6x, and you can see that this is exactly what dv dy is, so it's equal to dv delta v delta y. And on the other hand, looking at the second Cauchy-Riemann equation, take delta u delta x, which is equal to minus 2e 2x sine 2y minus 6. Now comparing with delta v, there we can see that this is equal to minus delta v to minus 1 times delta v. In this case, we are saying that this delta u delta is equal to minus delta v so this is delta u delta y is equal to delta v minus delta v delta x. Now we have here that the Cauchy-Riemann equations, right? Therefore, Cauchy-Riemann equations are satisfied, which means that the function is analytic. Now we can proceed to finding the derivative. Now proceeding to find the derivative, which in this case is our step number 3. We calculate f prime of z in terms of partial derivative in terms of x, which is delta u delta x plus I delta v delta x. This gives us the partial derivative of u with respect to x is 2 e 2x cos 2y plus 6x plus the imaginary unit times 2 e to 2x sine y plus 6y. Now, having arrived at this point, we must take into account that we need now to migrate this expression to f of z, that is a function in terms of z, knowing that z is equals to x plus I y. Now, the other thing which can guide us a lot here is to remember that we said if the function f of z is analytic, then it satisfies the rules of differentiation which we saw when we're dealing with functions of ordinary or functions of one variable, f real variables x. In this case, we mean that since we've got fz equals to e to the power 2z plus 3z squared plus 1. We should recall that, or note that this parallels a function of real variable f of x, which is equals to e to the power 2x plus 3x squared plus 1, which we know that its derivative f prime of x is equals to 2e to 2x plus 6x. Now, then that suggests that if these functions satisfy the same rules like power rule and so on, then this prime will look exactly as 2e to the power z plus 6z, because we said it satisfies the same rules of differentiation like the functions of real variables. That is, if it is analytic. So this we've got to keep in mind so that it can guide us the transformation of this expression to a function of z. So rewriting that, we can write here f z prime equals 2. Now remember that this expression and this expression came from the expression e to the power 2z, so that is important also, so we can bring them together in the process of trying to recover that type of expression. So note that there is a common factor here, 2e to the power 2x, in both terms, which will then give us 2e to the power 2x plus cos 2y plus I sine 2y plus 6x plus I 6y. Now we note that here we've got that identity which stated that e to the power I theta is equal to cos theta plus I sine theta. And here we've got x plus y times 6, since 6 here is a common, x plus iy times 6, since 6 is a common factor here. So now simplifying, we write this as 2e to the power 2x multiplied by e to the power I 2y plus 6 brackets x plus iy. Now simplifying here using the rules of exponents, we get that this is equals to 2e to the power 2x plus iy plus 6 plus iy. So now you can see now I've got z there and z there. Then you see this simplifies to 2e to z plus 6z, which is actually the derivative which was suggested by considering that this being analytic would satisfy the same rules like the function of real variables there. Then this also helps us to check that we've actually arrived at the correct answer. So we've arrived at the expression we needed, f prime of z in terms of z in its simplest form. So I hope this serves as another example which must help you to go forward and do further practice. Now concluding, I would like to give you the following exercises to do your practice, and please make sure that in each case you give your derivative in their simplest forms in terms of z. Otherwise, for now, I'd like to say thank you for listening. Meet you in the next presentation.